A new study using NASA's James Webb Space Telescope analyzed the exoplanet Trappist-1d, an Earth-sized rocky world in the Trappist system. The TRAPPIST-1 system is located at approximately 40.66 light years from Earth in the constellation of Aquarius. TRAPPIST-1 is an ultra-cold red dwarf, also classified as an M dwarf, a small dim star that emits reddish light. It is slightly larger than Jupiter but more massive and relatively cool compared to stars like our own Sun. The star TRAPPIST-1 was discovered in 1999 by astronomer John Gizis and colleagues during a survey of nearby ultra-cold dwarf stars. However, the planetary system was not discovered but until 2016 by a Belgian astronomer during observations made at the La Silla Observatory in Chile using the TRAPPIST telescope. TRAPPIST stands for Transiting Planets and Planetesimal Small Telescope. TRAPPIST-1 gained fame as the system with the most Earth-sized rocky planet orbiting a single star, 7 in total, a record that sparked, of course, widespread interest for astrobiologists. At least 4 of those planets, the ones called D, E, F, and G, lie in the habitable zone, where liquid water could theoretically exist on the surface, raising hopes, of course, that there could be life. What makes this system particularly interesting is that stars like TRAPPIST-1 comprise up to 76% of the youngest stars in the galaxy, and if habitable planets can exist here, it suggests that many life-friendly worlds might exist. Because the system is close enough to Earth, it also enables detailed observations with telescopes like the James Webb Telescope, serving as a key testing ground for exoplanet detection techniques and atmospheric studies. TRAPPIST-1d is the closest planet to the star. Despite its position in the edge of the habitable zone, the planet does not appear to have an Earth-like atmosphere. JWST near-infrared spectrograph, or NIRSPEC, failed to detect the common atmospheric molecules such as water, methane, or carbon dioxide. The team conducting this study suggests possible explanations for this: a thin atmosphere similar to Mars, or thick high-altitude clouds like in Venus that obscure the detections, or no atmosphere at all, leaving it as a barren rock. The study highlights the challenges for planets orbit red dwarf stars like TRAPPIST-1. Although those are abundant, these stars are volatile and prone to flares that can strip the atmosphere of planets orbiting them, especially inner planets like TRAPPIST-1d, which is just 2% the distance from Earth to the Sun and orbits the star in just 4 Earth days. However, studying systems like this is crucial for understanding potential habitability across the galaxy. Astronomers are currently conducting studies of the outer planets, those named E, F, G, and H, because they are farther from the star's eruptions, and these might retain the atmospheres, although they are colder environments and their detection becomes more difficult. In any case, we will wait to hear what the studies in the outer planets reveal. If you enjoyed the information in this video, remember to subscribe or follow me.